Hey guys, thanks for coming to my in-service today. The reason we're here today is for lunch, of course. But beyond that, we need to discuss something. The Liebel-Flarsheim Angiomat 6000 Angio Injector, its clinical applications, OVP, theory of operation, PM, and then we'll break for lunch. Today I offer you the taste of louse. After lunch, we'll go back to the special procedures lab in radiology, and I'll demonstrate a typical injection. One moment, please. Before we begin, guys, let's thank Dave, our boss. Dave, you're great. Thanks, man, for letting me do this. And guys, don't tell anybody, but I'd like to thank Ron Jenkins in guest services for securing the van that brought us here, and John Davidson in building management for screwing the other people out of this conference room. Hang on, let's get started. The last talk I had with you was about the direct conversion receiver, and I started thinking, well, I haven't stopped because I never know for sure what I want to talk about. I have so many things I want to talk about, and I'm not sure where to start. I'm an old guy now. I don't do in-services anymore. Those days are long gone. Thank God. I realized, guys, that whether your receiver is direct conversion, DC, we'll call it from now on, or Superhet, it's going to have a mixer of some type. They all have an oscillator that serves as your tuning method, right? You got to be able to tune the radio. And they have an audio amplifier. And what I've shown here is, of course, a direct conversion receiver where the VFO is running at 700 hertz away from your incoming, the signal of interest. In this case, a QRP, or I talked about this in the last video, but I'd like to stress it. So that you've got these two signals, one coming from here, one coming from your antenna. The mixer is a complicated device. It can be incredibly simple in design, but its function is always fantastically complicated and serves as the thesis topic for PhD doctoral students, candidates, and such. And we're going to talk about a little bit of that here today, guys. So if a little bit of a light technical talk about mixer function isn't your cup of tea, you may leave. That sounded like an a-hole-ish way of saying. If it's not your cup of tea, it's okay, man. You take off. Do it. Have some fun today instead. Yeah, that's better. So I'd like to talk a little bit about a mixer, the function, and different types of mixers, okay? I'm going to try to keep this non-technical, okay? One moment, I need to show you a different view. But first, remember, guys, the difference between this frequency and this frequency is this frequency. In this case, these two frequencies are only 700 hertz apart. So this frequency is 700 hertz. It's your audio tone, right? Okay, hang on. Okay, different types of mixers. I've mentioned before that you have basically two types, active and passive mixers. And I've mentioned before in the last video that the integrated circuit based one, based on the SA612 IC, I mentioned its performance limitations. I mentioned its advantages and disadvantages. But I also said it's excellent. It's an excellent chip for use in Superhet transceivers, and it is used almost ubiquitously. Well, if ultimate performance is your goal, you wouldn't use an active mixer. You'd use a passive mixer. And I wanted to show you the schematic diagram of a diode ring mixer. You have your 4 diodes. It looks like a bridge rectifier. The only difference being these 2 diodes on the bottom are backwards. If you turned them around, you'd have a bridge rectifier. I mentioned that you have 2. I incorrectly said in the last video that you have 2 toroidal transformers. Well, you do have 2 transformers. They can be toroidal, such as on this. There you go. There we go. This Amidon type FT40. What is it? What is it? It's an FT37-43 core. But another great way of doing it, of winding your own transformers, is to use a binocular core. If you can see that. Damn. It's gone. I paused. Never to be found again. But there you go. It's a little ferrite core with 2 holes through it. Looks like a pair of binoculars. It's a binocular core. This is type BN 43-2402. Yep. And this is a type of core that I used in my Superhet. I'm sorry, well, that I used in the mixer in my W7EL DC rig. Okay? So that is a diode ring mixer. You apply RF to one input, you apply your local oscillator or VFO to the other input, and your output is your intermediate frequency. I'm going to point you down. One moment. Okay, that's a passive mixer, by far the most widely used in mixers. Let's talk about active mixers. I've mentioned, and I'll be continuing to mention, the type SA612 mixer oscillator IC. For that's the chip I used in my Superhet Design, and that's the end goal of this series, is to talk about my Superhet Design. But before I'm starting to want to get tappy. Before we talk about Superhet Design, we got to talk about the DC, the direct conversion receiver, which we've already done, and we've got to talk about mixer function. I really want you to understand that the mixer's output is the difference or the sum between the 2 input frequencies, plus a whole bunch of garbage. And I'm going to talk to you about garbage in a moment too, okay? An active mixer, an active discrete mixer, can be as simple as 2 FETs in series. Okay. We don't need to talk about this on this sheet. One moment. Let's look again now at an actual circuit around the type SA612 mixer oscillator IC. This is an actual functioning circuit. This is the circuit taken from the MFJ 9020 20-meter Superhet transceiver. And look at this, look at the low parts count right here, guys. That's your VFO. You know, that's your whole VFO. What have you got? 4 caps, a tuning cap, And in their case, they used a Toco-style adjustable slug coil, and they use that slug for calibration. In my design, I don't do that because those are almost impossible to obtain these days. I try to design my radios without using those little Toco variable inductors and IF transformers. Anyway, look at the low parts count. You know, that's the usefulness. That's the value of this mixer oscillator chip. And it's also used, in this case, it's the input to the rig, but it's also done in almost the same exact fashion for the BFO stage of the Superhet rig. And I did the same in my design. I just wanted to show you the simplicity and the beauty of this chip. Look at the low parts count. That's your VFO. And then you apply, you have input filtering from the antenna, and the signal goes on to your IF strip. One moment. Okay, guys, this is where things get pretty dull for many. And I'm going to try to limit this kind of talk when we get into the first of the Superhet talk about my rig. You know what I'm trying to say. I'm tongue-tied today. So far we haven't started the series proper. I'm preparing you, trying to get my thoughts in order is what I'm trying to do. I've mentioned that the main function of a mixer is to mix the incoming RF with your local oscillator or VFO signal to produce your intermediate frequency, right? The sum and the difference. You can use either, they're equal. But I've mentioned that the mixer generates a whole bunch of garbage, and you know where that garbage comes from? It's down here, man. I zoom you. Oh, I cannot zoom you. One moment. This phone's so much different to use than my old one. This is where the garbage comes from. This is its main function right here. It produces these two signals of interest, right? And then it goes on to mix those two signals, those two IF signals. It goes on to mix them again with the RF. The sum, it mixes with the RF. The difference, it mixes with the RF. The sum, it mixes with the local oscillator signal. The difference, it mixes with the local oscillator signal. And it takes the output of that and again mixes it with the RF and again mixes it with the LO. And it you know what I mean? And it ripples on and on and on, and it never ends. The mixer products never end. They diminish in strength. These two are by far the strongest, and they get weaker and weaker as you ripple on down the mixing chain, if that makes any sense. I hope it does. That's the garbage, and that's why you have an IF filter, so that you only take this or this and stop all of this. Hang on. I pause you. Let's look at a different case where we're using a much higher IF frequency. In this case here, guys, will help you understand, maybe it'll help you get your hand on the use of mixers and your choices in frequencies, your choices when designing a transceiver or receiver or transmitter. Let's say we're on 20 meters again, okay, 14 megahertz. But let's say I can use whatever IF frequency I want to use in my design, okay? This is a frequency I tend to like. If I want to end up with a 16 megahertz IF, remember, guys, you can take the sum or the difference between the incoming signal and your local oscillator. Please get used to referring to your VFO as a local oscillator. That's the correct term, guys. So let's look at a case where your incoming signal, it's for the 20 meter band. And let's say I want to use a 16 megahertz IF. I've got a bunch of 16 megahertz crystals in my parts box, and I want to use them, damn it. Your local oscillator can either run at 2 megahertz, in which case you're going to use the difference signal out of the mixer, or it can run at 30 megahertz, in which case you're going to use the difference. What did I do wrong there? You know what I'm saying. One moment. I'm having a real hard time forming my thoughts today, right? I haven't said anything wrong just now, but I haven't said anything clearly either. Now then, I can use a local oscillator at 2 megahertz. 2 plus 14 equals my IF of 16. Or I can use a local oscillator at 30 megahertz. 30 minus 14 equals 16 megahertz IF. Right? You can use the sum or the difference. I don't know if you've ever heard of the terms high side injection or low side injection. That's where they come from. The word injection, it's a fancy word for saying applied to the input of. If I inject a signal to my mixer, what am I doing? I'm applying a signal to the input of my mixer. You know, what other word could you use for, you know what I mean? High side inputting or low side inputting. I don't know, man. But that's where the terms come from. And that is the gist of it. That is the gist of mixer function, as I'll be talking about in my transceiver design. This, having got this out of the way, now I can be far less technical. The rest of the talk will be far less technical. I'll try to keep it non-technical. You know, we'll be starting out with a block diagram, right? Yeah, so anyway, man, I pick you up. I show you something. The bands are, that was out of focus. The bands are wide open, man. They have been. Check this out. Hang on, let me zoom in. My little Superhet talk series cost me a couple subscribers. I think it's a hoot. We'll see how many more, please. I can't use the analogy of rats jumping ship. I'm not going to call people that subscribe to this landfill rats. Hey, that's classy. Slide them around some more, Chuck. Anyway, man. Boy, this camera. Thanks for watching. I'll be back with the first real part 1 of the Superhet talk. This was all preparatory talk. This is all just mumbo jumbo by Blozo. I hope you're well. Thanks for watching. Catch you soon. Bye, guys.